All right, welcome back to web development. Let's see. So we are officially in the second half of the semester, with mostly focus on the building the client side of a client server application, right? So we had said at the beginning of the semester that building web applications consisted of following a client server architecture where would split up the application into two pieces, right? The client side and the server side, and would focus the first half of our semester on the client side, which consisted of a React.js application that ran on a browser, and so the browser constitutes the client of our client server application. And there are some limitations of what we can do in the client. I mean, we don't have access to the file system. We don't have access to the full access to the operating system. We have kind of limited access to the network. And so to mitigate this, right, we're going to build a server, right? We're going to focus on the server side of the client server architecture. And this server is going to be able to execute outside of the browser, without the constraints that you get, right, running inside of a browser, right? So we'll be able to have full access to the file system, to the operating system, full access to the network, and eventually, later on in the semester, it'll have access to a database. Okay, so yeah, so that will be the focus of this lecture, the next couple lectures. Okay. All right, so let's talk about building a node server, right? A server application. Right, so what we want to be able to do is create a server application that we can integrate with from the client so that we can escape some of the limitations that we have on the browser. So this is the general architecture of what we're building, right? We've been focusing mostly on the first half, right, of this client server architecture. So in the client, we've been basically using a browser, and in that browser we have JavaScript that we are running inside there, and we can do a fair amount, right? We can interact with the user, we can consume a stream of events, as a user types at the keyboard, clicks their mouse, right there, they and they consume a graphical user interface, right? They fill out forms, and you can maintain state, right? We can have state variables in here, and we can see that we can manipulate the user interface, as the user manipulates the state of the application of the client. But as you might have noticed, right, if you refresh the screen, all those changes go away, right? So we don't have really a way to make the changes permanent. Well, that's not entirely true, right? Clients do have some limited capabilities of storing data in a local database, right, in the browser, but that would only be available in that one browser. Like if you try to use another browser, obviously the application would not be available, even though you could, hit the remote server, running your web application on Versal or Render or whatever, right? The data would be stored in the browser that you were using. If you use a different browser, you would not have access to that data. Instead, what we want to do is be able to make those changes permanent, right? If I create a new course or delete a module or edit an assignment, I want those changes to be permanent, and I can't do that only with a client. So we're going to rely on the server, right? The server is going to be an application that runs outside of the browser, so it doesn't have any of the constraints of the browser, right? It will have access to the file system, to the network, right? The full access to the operating system, right? And eventually to a database, right? So it can make those changes permanent, either saving those changes to a file because it can access the file system, or better yet, right? It will be making those changes permanent in a database. Okay. You can also store it in its own memory space, right? And the server as long as the server is running, right, even if you refresh your browser, the browser can always come back to the server, right, and retrieve whatever information it might have created, right, in the server. Right? So the server is going to be now the repository of the state of the application. So the application state now is going to be maintained by the server, so that if the client, just refreshes and loses its way, right, of whatever it was remembering, and all that is gone because we refreshed the screen, the client can always come back to the server and say, hey, where was I? What was the value of whatever variables I had? And the server can then provide that state. Now, the state really is going to be maintained in two places, right? The application state will be maintained on the server, but the client will maintain a copy of that state, right? Only for convenience purposes, right? We don't want to have to go out to the server for every single thing, right? So we are going to use, a cache on the client, not really a cache, but we're going to copy some of a snippet of the state that is maintained on the server. We're going to copy it in our reducers, right, or our local variables, right, in our pages and our components, right, and then use that to render our user interface. But no longer is the client going to be the repository of the single source of truth. That is going to move over to the server. The server is going to be the single source of truth, right, that the client can then copy over only for rendering purposes. Now, for this lecture, right, we're going to be using the server memory, right, to store the state of the application, right. But if we really want to make things permanent, we're really going to have to integrate with a database, right, and then store in the database. And for that, we're going to do that in the next lecture. But for this lecture, we're going to be using the server's memory, right, as our place of storing the current state. Okay. So for the server, we're going to be using Node.js, right? And I mean, we could have chosen any number of technologies for our server, right? There's certainly Tomcat, there's JBoss, there's all sorts of servers here, right? There's Python servers, there's .NET servers, there's any number of vendors, right, that provide an implementation of a server. The server is basically just a piece of software, right, that runs indefinitely, meant to be running 24/7, right, and can consume or can listen for incoming HTTP requests, right? Now, those are HTTP servers. Certainly, there are other types of servers. There's mail servers, there's FTP servers. We're going to be implementing an HTTP server, right? That is going to be able to listen for incoming HTTP requests, right, from the client. And this is how these two pieces of software are going to integrate, right? They're going to be able to send requests from the client over to the server, encoded using HTTP, and the server is going to be able to respond to the client, with an HTTP response. And so presumably what happens is that the client asks the server to do something, right? The server obliges, right? Does the actual work, right? And then responds with either it's successful or not, or whatever new state of the application. So for instance, instead of adding courses to our local arrays or deleting from here, what we're going to do is that instead those data structures are going to be maintained on the server. And the server is going to expose several HTTP endpoints, right, that the client can call. We're going to send requests out to the server, right, to add a course, delete a course, update a course. So, and we're going to keep a copy of those modifications here in the client. And the trick here is to make sure that the changes in the data structures that we have here cached on the client always have to match whatever actual data structures live on the server, right? So we have to make sure that, if we do send a request to delete something, right, we would, wait for a response that it was successful, and then we would, do that operation here in the client as well. We could always say, well, if I created a new course, the surest thing to do is to ask for all the courses just to make sure that I have all the courses, including the one I just created. But that would be too expensive, to ask always for the whole data structure. Even though the server is maintaining the collection of courses and modules, it would be very expensive, right, to always respond with the entire data set. So we typically, what we have is a copy or a shallow copy of the same data structure that lives in the server, but we make incremental changes here on the client, making sure that if we get a success response saying, yeah, I was able to create or delete or modify, then we make those changes as well here on the cached copy, right? If we get a successful operation, right? So we do incremental changes here, again, with the hope that whatever changes we made to the remote data structure are also, right, synced up here with the client. When we introduce databases in the next lecture, right, it'll be even more complex, right? Now the data needs to be maintained and synchronized in 3 different places, right? Cached on the client. The server now will have a cached version of the real data, but the real data now is going to live in the database, right? And again, we're going to have to copy a snippet of the data, the rows or collections or objects that live in the database. We're going to have to copy them in the memory of the server, and then the server will have to share it with the client, right? And the trick is that we have to make sure that that the data is always consistent, right? And it matches across all the various tiers, right? As the data moves from the client to the server, down to a database, and then back to the client, right? So that is the challenge, right? That will be the focus of the second half of the semester, okay? So yeah, so we're going to be using Node.js to create our server. Again, we could have chosen Python, .NET, Java, any number of technologies to create our server. But we're going to be using Node.js. It's a very, very easy technology to work with, and it's very easy to create HTTP servers. Just with a few lines of code, you have a running HTTP server. Right? Also, it uses the same programming language that we've been using for the last couple of weeks, right? And also the data structures that we're going to be sending back and forth between the client and the server are all going to be formatted in JSON format. Right? So that it's very convenient for the client because the client is running JavaScript. So it is convenient that the data is already configured in JavaScript object format. Same thing with the server. It'll be very convenient as it receives the data already formatted in the correct format, right? Just to work with that data structure, right? And later on, when we introduce databases, we'll work with Mongo, which also works with JSON, objects that you store in the database. So it'll be very convenient that the data is always formatted, in the compatible to all our 3 layers. We've had other versions of this course that used, for instance, Java in the middle here, and then use a relational database here, right, in the database. And that adds the complexity that the representation of the data needs to be converted, right, in each layer, right? If it starts off with JSON here, right, then on the server it needs to be converted. If you're using Java, then it would have to be converted into a Java object instance, right? And then when you store in the database, it needs to be converted into a SQL insert or update or delete, right? And then vice versa, when you do a retrieval from the database, right? You receive rows in a relational database which needs to be converted into Java objects, which then need to be converted into JavaScript array objects, right? So the conversion layer, right, is more involved, right? It's more challenging. Here, the conversion is trivial because the format is always JSON, so it's very convenient. So yeah, so we're going to be using Node.js, which we've already been using Node.js throughout the semester, right? In the first half of the semester, we use it to create our React Next.js application, right? So it's already installed in your computer, right? And obviously we have the Node executable, right, in our a terminal that if you run Node, you can play around with some commands like console log. So we're going to create an entire application, right? A Node.js application that is entirely separate from the application that we already have for our React application, right? So I must stress this quite a bit that this is a completely separate application that has nothing to do with the application that we've been working on, right, in our React application. So make sure that it's not inside of the folder of our React Next.js application, right? It should be outside of that folder. In any case, as a sibling of that folder. So let me just illustrate just to make sure that it's clear, right? So we're going to create a brand new folder outside of the current project. So for instance, this is the folder for the project, right? We are going to be in the same directory, the same parent directory. We're going to create a brand new directory. Make sure that it's not inside your Next.js folder, project folder. So this is going to be a brand new project folder, right? And then just give it a name just to make sure that it's for this particular section. So it's a brand new folder, right? And it's empty. Right? So it's going to be canvas. Yep. And in here, notice that it's totally empty. And in here, we're going to initialize the project. We're saying npm init. And it'll ask you for the name of the project, right? And you can keep all the defaults. So I'm not going to give any other defaults. And what it'll do is that it'll create a new package.json file, right? Which has all the configurations for the project. Okay. So once we have that, right, in there, we can create a simple application. So we can either hear from the command, we can say cat hello.js, and this can say console log hello world. Okay. And then now we have this JavaScript file, and we can run it from the command. We can say node hello.js, and there it is. It prints out hello world. So there you go. Right. This is a terminal application that runs right from the terminal, and we're going to be building servers, right, using this technology. Okay. All right. So again, we want to build this architecture, right? We've been focusing in implementing the client, right, for the first half of the semester. And we want to focus on building the second half of the client server, the server side over here, okay? And then the way that these are going to talk to one another is through an API, or application programming interface. So there's an interface that is used for inter-process communication. So the applications talk to one another, and it's you're going to have two programs talking to one another. So you have an interface between two programs, right? And that's why they're called programming interface, right? These are interfaces between the two that are going to be talking to each other, right? That's programming interface, because they're going to be building an entire application. So it's an application programming interface, or APIs. And specifically, they're going to be using web technologies, right? Because we are going to be sending HTTP requests across the internet. So these interfaces, right, are using web technologies, right, HTTP. So to do that, we're going to install a library that is going to allow us to create these APIs, right, which is called Express, right? Express is one of the more popular libraries in the Node.js ecosystem, right? So let's install that. And what that's going to do is going to download the library, and it's going to create a local folder called node_modules. So this is a folder where the libraries that we're going to be installing, right, they're all going to end up there, right? If you take a look at your React application, you'll notice that it does have a node underscore modules. And again, I can't stress it enough, right? That this project, right, this folder, this is not inside of the existing React application folder, right? It's its own folder, right? It can live anywhere. We've put it as a sibling of the React project folder. Okay. All right. So now that we have installed the library, we can create the simplest of, right, using the following few lines of code. So for this, I'm going to open up that folder we just created. Right, this is our React application. Let's leave that alone for a second. I'm going to start a brand new file or brand new window, and we're going to open up that folder that we just created. And say open folder, and we'll go to NEU 2025. There, so this is the folder we just created. So let's go in there. There's our hello world application, and let's create an entry point for our application. This is the root application file, right? Index.js. Index in web, right, has a special meaning. Index often means the entry point, right, or the default file, right, if one is not specified, right? So it does have a special meaning in web. It's often, sometimes we use an alternative, main.js, right, as being the the beginning, right, the start, right, where everything gets booted up, right, and configured. So yeah, so this will be our top level file in our application. So in there, we're gonna create the simplest of servers. Let's paste it in here and let's talk about it and what it is. So here we have a require express. This is the library we just installed, right? And require is a keyword in a version, right, of the JavaScript language, what is referred to as CommonJS. Right? It's the equivalent of the import keyword that we've been using, for the last couple of weeks, right? The import, right, and export is fairly new. Well, not fairly. It's been around for a while, but it's newer than CommonJS, and is the more modern preferred syntax. And so we'll switch over to that in a minute. But just did want to point out that by default, the Node.js uses the older CommonJS syntax, right? But it's equivalent to the import. So we're importing the Express library, and we are assigning it to this local constant. And it's a function, right, that we are importing. And we just, when you run it, it creates an instance of the Express library. And it's typical that we assign it to a local constant app, like that, right? And what app does is that allows us to create the server. Right? It creates an HTTP server that you can immediately start and have it listen indefinitely, right, to a particular HTTP port. I mean, there are thousands of HTTP ports, right? The most common ones is the 80 port. 80 is the standard port. If you navigate to any website, right, on the internet, typically all those websites are listening at port 80. That is the standard port. Actually, it's so standard that you don't even have to type it in, right? If you go to Wikipedia, right, this website is listening at port 80. It is so standard, right, that you don't even have to provide it, right? So typically you would have to provide the port right here, colon, and then the port number, right? But it's standard, you don't have to provide it. Now, because we are developers, for developing purposes, typically we use a different port that is not the standard port. And different infrastructures use different ports, have gravitated to different ports, right? Now, for Node.js developers, the most common port that developers use is a port 3000 or 4000. Those are the common ones. If you're using implementing Java, typically you would maybe use a port 8000, or if using Tomcat, maybe it's like 8080 or something like that. And that creates an instance of the server running in the background, listening for incoming HTTP requests at that particular port. Okay. Now, once you have a server listening at that particular port, you can only have one server listening at a particular port. You can have many servers, each one listening at different ports, right? But it's you wouldn't have more than one server listening at the same port. Okay. Now, once you have the server up and running, you can declare certain paths, right? You can have the server say, "Hey, server, listen for requests to, for instance, to HTTP localhost, HTTP colon 3000, right, at port 3000, and then after, whenever you go to a server, right, typically you provide a path, right, of something that you're looking for, right? And so this is a path. So the path is provided to the server, and the server can parse this. And depending on what path that is, the server can then respond to different things. Like this one, for instance, the server responded with this content of React. And so here we can program the server to listen for different paths. And we say, well, if the path is /hello, so this would be the path, everything that follows everything beyond the beyond the domain. This is the domain over here. So this is the path. So after the domain, right, this is the path that can be mapped here to the server. You can program and say, well, if the path is /hello, then notice that this is the first argument to the get, right? And then you can define a function here that runs. So this is a function that is, notice it's using the arrow syntax. Let me remove that. There we go. So there it is. It's a function right here, right? That it's an arrow function that gets called, if the path matches hello. And that function takes two arguments, right? Request and response. So these two objects over here, right, represent these two pieces of data, right? The request that comes in from the client and the response that the server is going to send back to the client. So these two objects, right? These two objects, the request and response, allows this function to participate, right, in this communication, in this loop, this communication loop. Okay, it allows them to consume whatever data is coming from the client and then generate a response back to the client. So it allows us to talk, receive something from the client and then send back something to the client. So these two objects. Here we are ignoring the request. We are only using the response. So we're saying, hey, response, send back this string. So basically we're saying here from the server, send back to the client, send back this string of hello world. Okay? And this is just a few lines of code. This is an HTTP server listening at that port 3000, listening for a specific type of request. Now, this request is a GET request. There are different types of requests, right? And you can configure them all here. Now, requests that come into the server can be, one of four. Well, the most common ones is the GET request, the POST request, the PUT request, and the DELETE request. Most requests are GET. For instance, when you go out to this website, right, you can inspect, right, and you can take a look at the network. When you refresh here, you'll notice that most of these requests, if you click on these, are all these requests, right? These are all GET requests, right? So this is the browser is making all these requests that go out to that server, for some for images, some for icons, some for other things. right? And this is the URL that it's using for all those requests, and they're all GET requests. See that? And again, we'll use several types of requests, get, post, put, delete, all of them. But the most common one is the GET request. And it means what you think. It means to retrieve or to get data from the server, okay? And indeed, that's what the server's doing, right? Is retrieving or sending back data, in this case, this simple string. Now, to run this server is very simple, right? Here we have the new index.js. We can run it saying node index.js, and this puts the server, forever listening at port 4000, and it's running at this specific machine. Now, this specific machine has a specific IP address, which we can hit, right, with our request. You can say HTTP colon, right, / and then 127.0.0.1, and then hello, right? And that did not work. Wait, what? Oh, I forgot the port. Listening at port 3000. There it is, our hello world. We can inspect and see that the network communication went out. That is the request, HTTP 127.0.0.1:3000, and then the /. This is the path. So this path matches this path right here, hello, and we sent back hello world. Right? Notice, and just make sure that we are hitting this one endpoint over here. Let's change this to hello world 123. Let me restart the server. Let me Control C and restart it. If I go back and refresh this, there it is, hello world 123, right? And you can see the request here, right? It goes out. It is a GET request, and you can see the response coming from the server is the string hello world 123. Pretty good. Now, the IP address 127.0.0.1, that's a standard IP, right? That usually refers to the local machine, little computer that you're running on, right? So all computers, they're all mapped to 127.0.0.1. Plus, they all actually have their unique IP address, right? Given by the internet card that you have installed on your machine. But this is a pseudonym, right? It's a pseudonym that refers to the local machine. Another common local pseudonym is called localhost, right? Which is, I guess, it's easier to remember instead of the IP address. And this works just the same way, right? This right, it's the same thing. It refers to the local machine. Okay, so you'll see a lot of using localhost 3000 for their next couple of weeks. Does that make sense? Now we showed you that we are using a slightly older syntax, CommonJS, right? But let's get back to our beloved import keyword, right? Instead of our require keyword using CommonJS, and we can do that by configuring in package.json. We can configure the type of the project. Right? So if we edit package.json, you'll notice that the type has the default CommonJS. This is the older syntax. I'm going to change it to instead module. We're going to save that, and we're going to restart the server. And notice that it fails because now it doesn't understand the keyword require. So we'll need to replace that with our beloved import. So we'll say import Express from Express, like that. And let's start this again. And now it's working the same way. Right? So we can refresh now. Yeah, it works the same way. Okay. So now we can use all the syntax that we've been using for the last couple weeks, right? As we would expect. Another thing to point out is that notice that if I make a change, right, if I remove this and I refresh the server, notice that it doesn't take effect right away. See that? I'm refreshing, it doesn't take effect. I need to stop, right, and restart, right, and then refresh, and I see the change. That's kind of annoying, right? So you can install a library install nodemon, and the book shows you how to do that. And once you install the library, you can use nodemon to start your index.js. Instead of node, you can use nodemon, right? And what this will do is that it'll start using just plain old node, but now it will listen for changes in the file, see changes, and then it'll restart the server. For instance, if I make changes and I save, the server will restart. See that? Restarting the server is due to changes. And so that, if I refresh, notice that the changes take effect immediately, right? There's no need for me to stop and restart the server. So it's very convenient. I strongly suggest that you install it, okay? All right, server routes. So server routes, very similar to the routes that we've been using in our React application, right? These are just what? These are folders that, or paths that map to certain files, certain pages that are then sent over for rendering in the client. On servers, we have something similar, right? But we kind of have virtual routes, right? As opposed to doing physical files and directories that we put files in there. We can create our own paths, right? As a string. Okay, and then we can configure that the server so that if we have an incoming path, then the following function should run. Okay, which is somewhat similar to what we have on the client. In the client, right, we put pages in certain folders, and when we navigate to based on the path in the URL in a browser, right, we are sent back either a page or a component, right, and then that's what we render on the browser. So similar thing here. If a particular path matches, right, then we respond, right, with a particular piece of content. And so it's common to group together several of these routes into its own routing file, right? So here we have hello, right, that is declaring two different routes. One is the hello that we had before, and then we have a default route, right? Because this kind of like the root route, right? That matches the root context to respond some default message in here, welcome. So let's do that. Let's our hello. Let's replace this. And so basically what we're doing is that we're going to move any of these routes from here. We're going to move them over to a file, right? That's going to declare all those routes. It's going to group them all together and declare several of these, right? That one path here, another path, right? And now these paths all need to be unique. They cannot collide. I mean, they can, but if they do, then last one wins, right? So if I have a hello here, and they match, then obviously they can't both exist, right? The server can only respond from one of them. So basically, last one wins is the rule. Okay, and so it might not be what you want. So just be careful, right? That you don't inadvertently create colliding routes. Right. So once we declare these, right, they are just hanging there. Nobody, this app here needs to be passed to it, right? Notice that we're not reinstantiating app like we did index. So we don't create a new Express instance here. Instead, there can only be just one instance of the app, right? And then this has to be shared with the rest of the application. So what we do is that we import all those other route files, right? And then we pass an instance of the app, right, to the routing file, right? So that now we have a reference to the app Express instance, right? And then we can declare all our routes. And notice that this should have restarted the server, perfect. Right? So that we should be able to hit the hello, there it is. Live is good. And also we can see the default one with no, with a root context or the root route, right? And we're saying, welcome to full stack. So this is the default message from the server, right? Welcome to full stack development. Okay. So we're going to be creating lots and lots of these routing files, right, that collect all these routes. Also notice that the syntax of this routing file, where this declaration of the path and then associate to this function, right? So that, basically saying that if it matches this path, then run this function. If it matches this other path, then run this function. Now, some folks find this syntax a little hard to read, in particular because this function right here is embedded inside of this get, right? And I found it, somewhat hard to read as well, right? So an alternative is to move these functions out of here. So move these functions, cut them out of here, make an actual function, const, say hello, like that, right? And then here provide a reference to the function instead, right? So same thing here, cut this out and I'm going to say const, say welcome, that, right? And then here we have say welcome. So I think this syntax is a little bit easier to read, right? Where you implement all these functions and then you tie them to the appropriate path, okay? But either one works. So let's go through several exercises that is going to allow us to practice some really basic skills on how to establish communication between the client and the server. All right, we're gonna, in particular, we want to know, how do we ask for data? How do we pass data to the server? Right? How can we encode the data? Right? And how can they share data amongst the client and the server? So first of all, we'll create in the server, we'll create some code, and then we'll have to write some code on the client, right? So you'll see me go back and forth between the server and the client. So we're going to be working in two different projects, two different code instances, right? And some places I'm going to be editing the server. So this code is going to be the server code. And in the next slide, I'm going to be implementing some code in the client, because again, the ultimate thing what we want to do is to have these two guys talking to one another. So sometimes I'll be coding in the server, sometimes I'll be coding on the client. You just follow along. In the book, right, we do tag, each file, just to, as a convenience, we'll tell you, well, this is a server file and this is a client file, but you should be able to tell, right? I mean, if you're using an Express instance like app, well, that's obviously the server side, right? And if you see tags like this, right, in HTML, well, that's obviously, on the client side, okay? But yeah, if you follow along in the book does tag them conveniently so that if it's a server or a client file. So we're going to create a server 5 index file where we're going to implement several examples, several exercises, right, so that we can practice. So let's create first the lab index.js, right, to get started. So we have that, and in there, we're going to have a lab5 that is going to receive an instance of the Express instance. It's going to declare a new welcome, lab5 welcome. Right? Again, if you prefer the syntax const lab5 hello, that, right? We can, oh, yeah, way too many. There we go, lab5, perfect. And once you declare that, you do need to declare, import it inside of the root server. So import lab5, right? And then pass the a reference to it. Now the server should have restarted. We can see that, hopefully, yeah. And so we should be able to now hit this URL, lab5 welcome. It should say welcome to lab5. Let's see that. We can go out to the server here. And we should be able to say lab5. Lab5 what? Lab5 welcome. So welcome. There it is. Welcome to lab5. Okay, perfect. Okay, so once we've done that, we've imported it. Now, instead of me having to type this in the URL, ideally, I would, retrieve this either by navigating to this URL, maybe clicking a hyperlink or something, right? Or even better, I would be using some API, right, to generate the HTTP requests, with the GET. I would programmatically do this, right? I would programmatically do that. Right now, it's manual. I type it in, right, and the server responds. But I want to be able to automate this, right, so that these applications are truly integrated, right, talking to one another programmatically. Right now, we're doing everything manually. In particular, right, we're going to create a hyperlink on the client so that if I click it, it'll navigate there, right? So let's try that. Let's so we have the other project, the Next.js project. Let's see what branch we're there. Okay, that's good. That's good. Let's do a checkout -b a5. And in there, right, we can create a new lab called lab5 here. So new lab5 page.tsx. And let's create in there this lab5. Let's paste that in there. Okay. And we should be able to navigate to this. Let's see. So this is our server. Let's create a new tab where we can start the client. So we're going to go up one, and then we'll go down to the client. Again, they're not in the same folder. And we can do npm run dev that listens to. Oh, so 3,000 is already taken. See that? 3,000 is already taken. So, right, this server, it'd be a good idea if the server is listening at a different port. So let's do that. Let's go back to the server and change this so that it listens to port 4,000 instead. Okay, so if we restart the server here, there we go. And now I can restart my local React and port 3,000 as always. There it is, 3,000. So we should be able to navigate to our client here, localhost 3,000, and navigate to lab5. Oops, that's so huge. Go labs. I don't have a link to lab5, but let's go here, right here, lab5. So there it is, lab5, and we click on welcome. It navigates to welcome to lab5. That's what we'd expect, okay? Now this, obviously this communication is very rudimentary, right? It's just, navigating to the URL where the server is listening. What we want is something a little more sophisticated, right? Without me even clicking on the URL, right? Maybe, when I first navigate to the page, right? Or because of some logic, right? Or because I'm adding something, removing. So let's practice and see how we can integrate these two guys, right? The server and the client. Right, so first of all, let's talk about environment variables. So environment variables, notice that we are navigating to this localhost 4,000. Now, this is fine, when it's running locally on our machine, because our machine is indeed localhost, and we are indeed listening to port 4,000. But when you install these servers, either in AWS, right, or render.com or wherever, these are not going to be the name of your machine, and that's not going to be the port where they're running. So how do we deal with that, right? I mean, it would be very inconvenient that, for development purposes, I use localhost 4,000, but then I have to remember when I deploy it when it's running, right, in Versal or Netlify or whatever, right, that it should use a different, server name, right, and a different port number. So what I want to do is to have a variable instead that, depending on the environment, the variable will have different values. So locally here, the variable should be localhost 4000, but when it deploys to Versal, it should be something else, right? So I don't want to have to deal with that here. We're going to declare a variable that can be then configured in different environments. So to do that, we are going to create a file called .env .development, okay? Or it could be just .env as well. But just make sure that we are in the development environment. And here you can create any number of name value pairs, right? We have a name equal to a value. These are all strings. And then wherever you see HTTP localhost 4000 hard-coded, you can instead use this variable name, okay? Which locally here in my local development environment has that specific value. But when it gets deployed to, say, Versal, the environment variable could have a different value, right? And point to the server that, right, that you're using for deployed in render.com or AWS or whatever it is, right? And so this allows you your source code to be oblivious, right, of the actual value, right? It'll use just a variable instead, okay? Okay, so once we have that, we can import that environment variable and use that instead of this hard-coded value. So here we have an exercise, right, where we illustrate that, right? So we'll create here an environment variables.tsx. So this is on the client side, right? This is on the browser side. Now, equivalent, we do have something like that on the server as well. So let's do environment variables, and here we have, right? There it is. So we have to access that environment variable that we declared here, right? So this is the one we declare in the .env. That one, see that? There it is. And so we can load it up using the process.env variable, right? The process.env takes a look at all the environment variables either declared in your .env files or even in your operating system. Your operating system also maintains environment variables, and they're all accessible to you using process.env. Okay? And so here we'll copy a local machine, and then we're going to just load it up over here. Environment variables, import, and let's see, local 3000, labs 5. And there it is, see that? HTTP localhost 4000, we loaded up, and that value is now available to us, all right? All right, yeah, so I have that. We can do the same thing here. The same thing we did the environment variable, we can do the same thing here. And then this, instead of being hard-coded, this could be an expression. And this value right here can then just be HTTP server. See that? And so if I click on this, it should still work. Okay. All right. Now in the server also, we're going to do something similar. Now locally, our server on the server, we're also listening at port 4000 and localhost. But when this runs in render.com or AWS, the server too here, we cannot guarantee the port number that we're going to get. Right? This port typically is assigned at runtime, and typically it's available as an environment variable called process.env port. Right? So we're going to use that here and say, well, if it's not defined, then default to 4,000. But if it is defined, which it will be, when this deploys to render.com or AWS or whatever environment you're running your server on, it'll use that port instead, right? Otherwise, this would only work locally, but it would fail remotely. Okay. All right. All right. So let's take a look at path parameters. Let's see, how is it that we can communicate with the server. Now, there's several ways that we can send data to the server, right? Oftentimes, we send data by path, right? We can say, so the content in the path itself is data that can be parsed, right, by the server. And it could be hard-coded data, right? Or it could be, some mathematical things, and I want to add, 2 plus 3 or something, right? Where these values can be anything, right? It can be 4 plus 6. Right, so some of it could be hard-coded strings like add or lab5, or some of them could be some variables like this. Okay, so how is it that we can parse the URL, the path name? Okay? So the way we do that is by using the request params, right? So in the when you declare your routes in the function that handles the route request, right? We said that these two variables, right, are allow you to participate in the communication between the client and the server. So this request object holds everything that has to do with whatever's coming from the client. So the client will send information, right, and either encoded in the URL, encoded in the JSON object or in headers, right, in the everything that comes in the HTTP request. And this allows you to parse that information. So if it's in the path, right, with name parameters, okay, it'll parse them out and create a map based on that path. So it'll try to pattern match, right, that path and name these placeholders, right? These are the path places, right, that we have named A and B. And if there's data in there, right, it'll parse it out and create a map or an object that has the properties that have these names. The property names will be those names, and then we can extract them, destruct them. Then, these usually are strings. We need to parse them into integers so that we can do, arithmetic addition and whatnot. So let's try it out. So on the server side, we create the path parameters to have this content. So this is an example of a very simple calculator. Oh, it's misspelled. Subtract. Sorry, English is not my first language. Oh, difference. Yes. Subtract. Okay. And so yeah, so it parses the A and B, right, and then sends back the string representation of the response. Okay. So we are going to load it into our index. So import our path parameters, right, and then pass app. So we should be able to now to the server say lab5 at 4.5 returns 10. See that? Or we can say subtract 4 from 6 from 4. That's -2, right? And so now again, this is me interacting with the server directly from the URL, but the exercise asks you to actually. Oh, okay. So we imported it from lab5. What I did is I imported directly from the index. That's fine. Either one is fine. But then in the client, we also want to interact with it. So we could create, like a tiny little calculator, right? Maybe a couple of input fields, right? The parameters. So in lab 5 here, we can create our path parameters TSX that is going to create a couple of state variables where we can edit, the values that we want to add, and a couple of form elements, right, that allows us to edit that information, all those two values, and then we're going to encode. We're going to create hyperlinks that is going to encode in the URL, right, the A and B state variables that we have here. We're going to encode it so that when you click on it, A plus B, then it's going to send it over to the server. Right? So let's see, we can put here in our lab 5 pages, let's see, we can say path parameters, put a couple of, there we go. So if we go here and go back, uh-oh, what am I missing? Use state, oh, it's a client, needs to be a client component. The path parameters, I guess we can make the whole thing use client. There we go. So we can edit 24, 34 minus plus. You can call plus here, right, or minus like that, right? And we can edit obviously different values that we can add, right, or subtract those two values. Okay. All right. Okay. So another way that you can send data to the server is through query parameters. So in this case, instead of encoding data in the URL as a hyperlink, slash whatnot, you have a URL, you encode it at the end of a query string, right? Notice the question mark at the end of the URL. See that? And then after that, you're allowed to create a list of parameters encoded in like name value pairs. So name equal value, ampersand, name equal value, ampersand, name equal value. So that's a different way of encoding it, right? Instead of using in the path, you encode it at the end of the URL using a question mark and then name value pairs in there. And then delimit it by this ampersand, right? So that this reads, operation equals subtract and A equal 2 and B equal 3, something like that. Okay? Now, once this URL reaches the server, in the server, you can then parse those parameters using the request.query. Okay, this is different from the one which we're using request.params, right? Nevertheless, it's the same thing. It's a map, right, that is generated when we parse that URL with the question marks, right? And then you are given all the properties here. We're extracting it using the destructor syntax, extracting A, B, and the operation, right? And then, depending on the operation, we calculate the final results, if it's add, subtract, and whatnot, right? We parse those values, right? And then we compute the result and send it back, okay? So let's take the query parameters on the client, on the server side. Let's see, node. Oh, this is a different one. There we go. So here's the query parameter. Let's create one right here. And with this content. And so again, what it's doing is that it's, this, by the time it gets to this calculator, right, we say /lab/calculator, right? We are going to encode at the end of this a question mark, okay? And now the path is what's going to cause this to run, not the query. The question mark is optional. You can provide no question mark at all, right? But nevertheless, it would match this path, right? And then it'll parse out the question mark, right, with all these parameters, and depending on that, it'll respond, right, depending on what the operation is and what the values are, right? And we can then, import the query. We say, import query parameters, and then add the app over here, and we can illustrate that right here. We can say, let's see, we can say lab 5, this calculator query, operation add, then and A equal 5 and B equal 7, right? And notice it returns 12. The assignment then goes on saying, kind of doing the same thing we did earlier, where we create a little calculator for the query parameters. So real quick on the client side, we're going to create a little form to play around with these query parameters. So we do RFC query parameters. So in here, we're going to copy and paste this too. We'll need to import all these guys, right? We'll need always a state variable. I guess we could copy it from here. State variables here. We'll need to import this guy, right? And what else? We'll need the HTTP server. We'll copy that too. And what else? I think that's it now. And we're going to import this into the lab 5 page. I'm going to put it up here so that it applies, it shows up at the top of the page, so we don't have to scroll too much. There we go. All right. Okay, so we can go back to our lab 5. There's our query parameter. There's our add, right? Okay, notice how it encodes. Right, there it is. So add, a whole bunch of spaces. Huh? Why a whole bunch of spaces? URL. Oh, because I do have a whole bunch of spaces. There we go. Let's remove all those spaces. And let's remove all those spaces. There we go. What's going on? Okay, so you can say class name, button, success, and maybe, and then do some styling here so it looks a little prettier. Class name, button, and button, primary maybe. Primary. Go back. There we go. Bottom. Start. There we go. Yeah, so we add that or we subtract, and you can change the value that you want to add or the value that you want to subtract. Right? And then we invoke it, and notice that we are encoding it in the URL after a question mark. See that? Then operation equals subtract and A and B. Okay. All right. So you encode it either way. We'll talk a little bit later. Why would you use one or the other? Right? You don't just willy-nilly choose one arbitrarily over the other. There are some best practices, and we'll talk about that in a bit. What about working with objects? Right now, we've been working with some primitive data types, right? Just integers, strings, and so on. So let's talk about something a little more interesting, working with objects. So how about just retrieving objects first, right? Let's create here a working with objects on the server side. So we'll create a working with objects. And so what we'll do is that we'll create an object. There it is, right? And that represents an assignment. And then here is a routing file, right? That's going to listen to this incoming request, HTTP GET, right? Lab 5 assignment, and it's going to use the response, right, to send back a JSON data, right, data that is formatted using JSON, okay? We'll obviously have to load it up in here. So import working with objects, and then pass in the app. So, well, we can try it out. We can go here and check to see, lab 5, what do we call it? Assignment. So assignment, and there it is. So it returns an object. Notice that I installed a little tool, right? A plugin to the browser, so it detects that the data is encoded in JSON. So it prints it out. It prettifies it, makes it pretty like this. It's not required, but certainly it makes it easier on the eyes. But I want to be able to access this from a page, right? So instead of just me typing it, so we can create a working with objects page on the or component in the client. Right, so let's create a working with objects here, and let's first create a hyperlink that just navigates to the lab files and what we just did by hand, right? And let's load up in the page. So this is working with objects. There it is, and we should be able to see it over here. There's working with objects. So if I retrieve the object, if I click on the hyperlink, right there it is. It just retrieves that one object. Now, it just retrieves the entire object. More commonly, you might be interested in a subset of that object. Maybe you only care to retrieve a small portion of that object, maybe only the title. And that's fine, right? You can create a URL, right? A path that explicitly declares a subpath, right? We said, you start with assignment. If you're asking for the assignment, then you mean the whole assignment. But if it's slash something, then that means that you don't want the entire assignment, but you want a subset. And here you can include, the particular property that you want. And so here we're tying it to get assignment title, right? That actually retrieves just the title, right? And so that now, if we go here, we can say that I want the title, and indeed just returns the Node.js assignment. Okay. The on the browser side, right? It would just be a new hyperlink, assignment / title. I'm not going to bother. You can play around with that. Okay, how about updating an object? Right. Well, you could update an entire object. You can update just a snippet of an object. More complex is dealing with an individual property. So the way we're going to do that is, for instance, what we can do is that we can receive a request, an HTTP request, that if you ask just for / title, I'm going to interpret that as you want to read what the title is. So I'll send you back the title. But if you provide me something beyond that, right, and some piece of content, I'm going to interpret that as you want to edit the title. You want to change it. You want to do something different. Again, all these URLs are arbitrary. I'm coming up with them as I go, right? Later on, we'll talk about what actual set of paths you should use. What's a good practice? What's not such a good practice on what these names should be. So there are some decisions a little later that we're going to, some best practices that we're going to use to determine what is the correct path to use here. It's somewhat, right? We are working in Lab 5. We're retrieving an assignment, and then you can kind of like a path. What a path does in a directory, where new paths that you add, you're digging into a deeper dive into a particular hierarchy or a specific branch of the file system. Here, same thing, right? There's a root assignment and there's a branch of the assignment, a subset of the assignment, and so on. So my interpretation is that if you have, it's something beyond the title, then I'm going to set the title. I'm expecting, from the params, I can parse out that path by its name, and then I can edit the local assignment, which is it's a constant. I might need to be a let, because here I'm manipulating it. I'm going to say assignment.title, changing it to new title, and then I'm going to respond with the new assignment. Hopefully the title will be edited. So I'm using request to read from the data that's coming from the client, and then I'm going to use the response, right, to send back data to the client. Okay. All right, so we have that, and so yeah, we can retrieve the title. So title, Node.js assignment, or we can provide a different value here. We can say MongoDB assignment 1, 2, 3. Okay, and indeed, notice that the object has been modified. There it is. Notice if I just ask for the title, it should return the new name. And if I remove the title, I should be able to get the entire object with the new title. There it is. See that? And this is permanent. Well, permanent as long as the server is running. If the server crashes and it reboots, we would not see this, right? So if I stop the server and then I restart the server, oh no, that's not that's the React server. So this one, I stop it and restart it. I go back in, I refresh. Notice that I get the original object. But as long as the server is running, I have a long running context of the data that I'm keeping around. Okay. So yeah. Here we have just an example of how would you edit the title. Just creating a form element where you can type in the assignment, so let's see. So we have a state variable. You can edit the assignment. Here's the URL. I think we have that already on the server for working with objects. We already have HTTP serve. Perfect. And we need this state variable that we can edit locally in a form. And we have the URL here. Okay, so let's put that in there. So this is so that we can have a form element and edit an assignment. And here we have the form element that allows you to edit the title. Okay, so let's add that here. Retrieving objects, form control. We need to import that. And let's see. Update the title. Okay, so if I change it to something else, we should be able to see the communication back and forth. Network. Let's put this here on the right. Okay, so node assignments 1 to 3. And do we get a button somewhere? Oh, there's a hyperlink. There it is, update title. So that should be a button. So if I click on it, it goes out to the server. Oh, it looks like it has a whole bunch of spaces in between at the beginning. Yeah, see that it's got a whole bunch of spaces. Let's try it again. Let's go back. So let's change it to assignment 1 to 3. Update the title. There's the request, right? And the object is indeed, right? The response is indeed Node.js assignment 1 to 3. Perfect. So we were able to edit it. Okay. Okay. How about working with arrays? So arrays allow us to work with something a little more interesting, right? As a collection of items, as opposed to just an individual item, right? So we're introducing ever more complex data structures that we can manipulate remotely, from the client. For instance, we have an array of to-dos. And the first thing that we might want to do is learn how to retrieve the entire array of to-dos. All right, so on the server, let's create a working with arrays. There it is. And we'll declare an array of to-dos. And here, working with arrays is going to give us an endpoint here that is going to allow us to retrieve all the to-dos from the server. Okay. So from the index, we're going to import working with arrays. So import working with arrays, and we're going to pass in app. Perfect. So we should be able to retrieve the to-dos. So lab 5 to-dos. There they are, the array of to-dos. Perfect. And now from the client side, we can just have a hyperlink that retrieves the array, right? And so I'll leave that to you. Now, this is a very common operation of retrieving all the items. Now, obviously, if these were thousands of items, then we have to rethink a strategy where, yes, the server has the entire data structure of thousands of items, but even that usually might be only a small snippet of all the items, right? That perhaps it's a local cache in the server, right, of the actual items that are in the database. The database might have thousands and thousands of items, of which the server might only have a small snippet, maybe a couple hundred. And then even here in the user interface, you might only have just a few dozens, right? It would make no sense to share all the hundreds of items of the collection to the user interface. So typically you would have some mechanisms where you could paginate over a large collection where you only show maybe 10, 20, 50 at a time, right? So you might provide here a query that tells you the name of the page, the number of the page, page number 3, right? And then count, how many you want. And you say, well, I want 50, something like that, right? But let's not complicate things. Let's assume that we have access to all the items on the client. Now, so a common operation is that you want a collection of items, and that's exactly what we're doing here, right? We're retrieving a collection of items. Another very common operation is that you might want a specific item. So maybe item number 3, or the item whose ID is 3. Right? So the more common way to encode that in the URL is in the path. So to-dos and then slash, say, 3, right? And then you return that particular to-do. So that's not implemented. Let's implement that. So that's referred to as retrieving items using primary key or unique identifier, okay? And so let's do that. So let's here. And we'll do that in working with objects or array, sorry. So we'll paste that in here. So basically it's, if you don't provide a primary key, the interpretation is that you want all the items. But if you provide a primary key, then that means that we want to parse that primary key, we want to find that specific object. We're only going to return that one object, right? So we're going to filter by primary key. And so now we should be able to if we refresh, there it is. We can retrieve that one item with the ID of 3 or 2, right, or 1, and then obviously you can provide a little input field where you can retrieve the to-do, and you can edit the ID that you want to retrieve. Okay. Now another common operation is that you can filter not by primary key, but filter it by anything else, maybe by the title, by some Boolean expression, or maybe a combination, right, of several fields. And now, whereas filtering by primary key, that guarantees that you're only going to get one object, right? That's the only object that you're going to get. If you filter by something else that is not necessarily primary key, then you're not guaranteed you're going to have just one item. You're probably going to get a subset of the original items, but it's going to be an array of objects, right? So a subset of the original array. So also convention that if you're filtering by primary key, the convention is that the path, right? You're going to encode the primary key as part of the path, like we did here. But if you're filtering by anything other primary key, maybe by the title, so anything that would cause to have a collection of responses of an array, then you should not encode the the title or the non-keys in the path. Instead, it should be encoded in the query. Okay. Now, for we're already using lab5 to-dos, which retrieves all of them. This implementation, get to-dos, and you respond with all the to-dos. But because we're going to encode the filter by a non-primary key in the query, well, it would be the same exact path with the optional question mark. And then, title, blah, 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 or completed, blah, 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 whatever, right? So it's gonna map to the same function, right? So what we're gonna do is that we're going to check to see, before we decide to return all of them, we're gonna check to see if we should first filter. And if we filter, then we're gonna return a subset of those to-dos, of those items. If there is no filter, then we're gonna decide to just retrieve all of them. Okay, let's do that. Let's add a completed flag to our to-dos. Okay, so yeah, we have there they are, completed. And so let's add to the get to-dos the filtering. We're gonna say, get to-dos here. We're gonna add this filter, right? If there is a query, if it's not undefined, then I'm going to filter my to-dos by the completed flag, so that I'm either going to return to you the completed to-dos or the incompleted to-dos, right? The one that are still pending. Okay. So now I should be able to either ask for all the to-dos, there they are, all the to-dos, or I can ask for the completed. I can say query completed equal true. There it is. So only the true ones, or the completed equal false, right? It only returns the one that are false, okay? Again, that's convention. If you want a specific to do, you filter it by the primary key and code it in the path. But if you're filtering by something other than the primary key, right? You can encode all the fields that you want to filter by in the query. So you can say completed false, and then assigned to Jose, and due tomorrow or something. Okay, so you provide all those filters, and then you run your filter, blah blah blah, and then return a subset of the items that match your criteria. Make sense? All right. What about creating new items? So to create new items, the convention to create new items is to use post, right? And now to use post, it's a little more involved, right? We need to do a few more things. So first, I'm gonna implement it using get, and this will give me a chance to discuss why would you not want to use get, right? And so so let's do it the wrong way first, and then we'll come back later and use the correct post. Okay. All right. So implemented using first. We're going to implement the function here. We'll call it create new to do. And so notice that. Let's see. I'm going to implement it right here. I'm going to paste it right there. Create new to do. And then here's our get. Okay, get right there. Okay, so first, here's one of the reasons you don't want to use get. Notice where I'm going to put it right here. See that? Okay, here, right there. Says get to do. Let's follow this, right? So it says get to do's create. We'll call this function create to do's, right? Should I put this a little closer so that they're right next to each other? Let me put it right here, like that. Okay. So it calls create to do. It creates a new instance of a to do object, right, with a unique identifier, right, some default title which we can edit later. And by default, the completed flag is false, and it adds it, pushes us to the array, so it becomes the last item. That's fine. And we're going to respond with all the to dos. Okay. Now notice what's happening here. Notice that I put this at the beginning, at the top. See that? And notice that if I would have put it down here, notice that it would not have worked. Okay, and the reason is that notice I have a placeholder here. That means that this pattern matches something that starts with lat5 / to-dos / anything, including the string create. That means that that it's these two are now in collision. / create as an ID actually matches both. So it's not quite clear which one you actually want. Is it the get to do or is it the create new to do? Okay. So now they're competing for the same URL, right? And so it turns out that the first one that matches is the one that wins. So if you say / create, it'll match this one, right? If you say / anything else, it won't match this one, so it will trickle down to the next one, okay? But if you have the other way around and it's / create, it'll match this one. It'll call get to do by ID. But create is not a valid ID, so it will fail, okay? So that's, you have to be careful in this particular implementation because it creates some collision. And so that's one of the reasons that that we separate when we are retrieving data from when we are creating data. When you have a creation of data, typically we want to use the same exact API that we're using to retrieve all the data, like this one, right? But we want to use the way we distinguish between retrieving data or creating data is by using a different HTTP method called post. But we haven't introduced that just yet, right? I'm just showing you why you don't want to use GET and you would prefer to use post, okay? So as part of that decision of or design decision of when you're creating versus when you're retrieving, one of the is that in these URLs, typically you want to avoid using verbs, like for instance here, create, right? Create or delete, anything like that, okay? Which obviously here we are breaking, okay? But again, because we haven't introduced post just yet, we will in a minute, right? But first I want to show you this, right? Why you don't want to do that. So let's try it out. We should be able to create a new to-do. Be able to go here and say to-dos create. It creates a new to-do, and at the bottom there it is, new task with a unique identifier. If I run it again, it'll create yet another one down below, right? And every time I call it, it creates a brand new one. I can retrieve all of them. I just say to-dos. There they are. If I refresh, I'm always retrieving the same to-dos. Right, so the data is being maintained in the memory of the server. Okay. All right. So similarly with deleting arrays, right? Because these are verbs now, right? Notice we have a delete at the end. Okay. That's a no-no. Typically, in a best practice, you don't want verbs in here. So instead, as we'll see in a minute, right, we would use the HTTP delete method, not the get method. Get usually is explicitly for retrieving data, not for creating or modifying data and things like that. But here we are misusing it only to make a point, okay? So let me implement this. Now, this one doesn't have the same risk from the creating to-do, right? Because it's not colliding with anything. So let's paste that in there. I do want to point out that it does have the encoding of the ID of the to-do that we want to remove, right? Which is a feature that we'll see repeated several times. That if we are operating on a specific item, right? Usually, again, you encode the ID of that item in the path that we're doing here. This one is for retrieving that particular ID, which get is totally appropriate. But here we're deleting. And usually when you're deleting is you're removing a specific to-do, which you want to encode and tell you which to-do you're talking about, right? So, and that's how we're doing it here. We are encoding the ID in the to-do, and then we're telling it that here's the delete. And then we're going to call the remove to-do, which what it does is that it parses out the ID from the params, right? And then it filters out, it finds the index of that to-do by that primary key, and then it splices it from the array and returns the surviving to-dos, okay? So we should be able to remove it from here. We can say let's remove 3. We say if we can retrieve 3, there's 3, that one. And then we can delete it. Let's say delete, and it's gone, and there it is. We only have 1, 2, and 4. Perfect. Let's take a look at updating items, right? And so what we're going to do is change maybe a field or property in the item. Here we are illustrating how we can edit, for instance, the title of an object of an item in an array, right? Where we are encoding first the ID of the item that we want to modify, and then we are adding the title that we want to modify, right? And so this is perfect appropriate in the URL encoding, but typically we wouldn't use get. Whenever we are modifying data or deleting data or creating data, typically we use post to create, delete to remove, and put, right, for modification. But we haven't introduced it yet. So instead, let's implement it using get for now. We'll revisit this in a minute. Let's take that. So here we are encoding the ID of the to-do that we want to modify, the property that we want to modify, and the new value of the property that we want to modify. And we are implementing in the function update to-do title. And what this will do is that it will find that particular instance of the to-do by primary key. Once it finds it, right, it'll update the title, right, to be the new title that is in the params, and then respond with all the to-dos with the new match. And oops, let's save that. So we can try it out and retrieve all the to-dos. So that's all the to-dos. All of them, right, because it restarted. So let's change item number 2. We can say to-dos 2, and we want to change the title, right, to say new title 1, 2, 3. Now it returns all the to-dos, and we'll see that indeed the new title has been modified. If we get the to-dos number 2, you see that it has the new title. Or if you get all the to-dos, it still shows that the item number 2 has the new title. Okay. All right. So let's talk about asynchronous communication with the server, right? So that the client and the server, instead of using synchronous communication, they're going to be actually using asynchronous communication. Yeah, so this is the architecture that we are implementing, right? Every web application consists of really 2 applications. One implements the client. In our case, it's our user interface built on top of React.js running on Next.js. And also the server, right, that is running outside of the browser and doesn't have any of these constraints of the browser. And this communication, actually, it's asynchronous. Right? Right now, what we've been implementing is really direct access to the server, either as us typing the URL in the browser or clicking in a a hyperlink on a web page. That's not really what we want. What we want is the page not necessarily navigating away from the page, right? Like, if you click a hyperlink, you basically are leaving the page. You want to stay in the same page and behind the scenes, send these requests out to the server, right? And receive these responses, behind the scenes, and then, update the user interface accordingly based on this communication back and forth, right? So we need to learn how is it that this communication happens behind the scenes, how we can integrate these two, right? Encode the data, right? and use an API as opposed to relying on users clicking or on a URL, right? That would navigate away from the page and then to the browser, to the server. So what we're going to do is that we're going to use a library that is going to allow us to talk to the server programmatically, right? Send these requests, this get, post, put, delete, right? Behind the scenes, right? Without having to us click on a URL or type it in ourselves, right? We can do this automatically. Yeah, and that library is called Axios. So let's do that. Let's stop the client, and we're going to install Axios, right? And then we're going to restart the client again. Once we have that, let's demonstrate us communicating with the server programmatically as opposed to clicking on a hyperlink. So let's create here. Let me illustrate creating an HTTP client. So in the browser here, right, let's create here an HTTP client. And what we're going to do is that we're going to load the Axios library, and we're going to send an HTTP request out to the server when something happens, some logic happens. In our case, we're going to click on a button, but in a minute we'll show you that we don't necessarily need to do that, right? So let's see. So we have here a button that we're going to click, right? That's going to go and fetch some data from the server, right? And then it's going to go out. It's going to respond from the server, and then we're going to set a local state variable, and we'll see it populated here, the data. And you might say, well, wait a minute, you're saying that you still have to click. And yes, that's true. But you'll notice that we're not going to leave the page. We're still in the same page. Okay, right? We never navigate away. We stay. We go to the server behind the scenes, and we catch the response coming back, right? And we can modify the local state of the screen, right? And re-update it. So let's put this in the lab 5. It is the HTTP client. Oops. And let's import it. There we go. And then we can see it here. Let's navigate back. There we go. Oh, back too far. So there it is. There's our fetch welcome. And here's the response from the server. Let's clear this out, and we can see in the network the communication that happens that goes out to the server. If I click on welcome from fetch welcome, notice what happens. It goes out and it fails. It goes out to 404. It's the wrong URL. Localhost 3000. Oh, not 3000. It's 4000. Let's see. HTTP client. Oh, this is the wrong variable. The variable is, what is the variable? env. It's this one. Okay, so let's paste it here. And here. That. Save that. And let's try it again. Let's refresh. Okay. So we are going to get another error. Okay, that's the error I want. Okay. So notice the request went out. Get localhost 4000. Lab 5 welcome. If we copy this and come here and paste it, the URL is good. right? The URL is good. The server should have responded with welcome lab 5. Instead, it responded with something uglier, right? It responded with a course error. That's a cross-origin resource sharing error, right? And that's actually what we expected. It's a course error like that. And so this is illustrating that there is a violation in the security protocol between the client and the server. I mean, early on, way back when in the 90s, when all this infrastructure was being designed, there was a lot of pushback from the idea that you would have JavaScript that was on the server that would be downloaded over to the client, and then in the client, the JavaScript would run, right? And so a lot of people pushed back on this and says, well, that's scary. What do you mean you're going to download an executable and I'm going to run it on my machine? What are you, crazy? And so a lot of effort was put into easing those concerns. And so that's why JavaScript running on a browser has very limited things, right, that it can do. It can't access the file system, the operating system, right? Can't access the database. And so, and one of the limitations is that it cannot just willy-nilly talk to anyone on the internet. It cannot make network connections outside of the browser. It is only allowed to talk back to where it was downloaded from. They did recognize that, that at least it should be able to talk to the server it was downloaded from, with the intent that, well, I mean, you already navigated to the server, you sort of already established some trust with that server, right? So that whatever downloads from there should be able to talk back, right, to the original server that it came from. And what's happening here is that our web application is running at localhost 3000, right? But our request is going out to localhost 4000. So as far as the browser is concerned, this is a violation, right? That the user interface is running in one domain, localhost 3000, but it's trying to talk to a different domain, localhost 4000. These are, as far as the browser is concerned, these are not the same machines. It's not the same servers, and it's true. This is being hosted by our Next.js server, right, running here, right? This is our Next.js server, but our other server is running over here, right? One is listening at 4000, and this one's listening at 3000. So it's correct. The browser is correct in flagging this as a potential risk. So how do we do this, right? Now, if the request was going out to localhost 3000, meaning the original Next.js, then it would have not complained, right? It would have let it through. But the error is because we went through to across origins, right? These are two different origins. Localhost 3000 and localhost 4000 are two different domains, two different origins. So cross-origin resource sharing, right? You want to be, basically what we're trying to do here is share resources that live in different origins. And that's what CORS stands for, right? Cross-origin resource sharing. We want to share across several origins, right? And so now we still want to be able to do this, right? And we can. But we need to do a little bit of configuration. We need to tell the server to let the request through. What happens here is that the browser goes out to the server asking, hey, is it okay? Right? Is it okay that this guy is talking to you? Right? It asks the server, is it okay? And the server can respond yes or no. Right? And so we need to configure that. So the way we're going to configure that is by installing a library called course. So npm install course. So we'll do that on the server. Stop this for a second. And install course. And there it is. We install course, and we're going to load the course library from the server. So here in the index, we're going to import course and then configure course. There we go. So what this configuration says is that create an instance of the course library. There it is, right? And then we're saying app.use. What app.use means is that typically we would do app.get, app.post, app.delete, and so on. And what this says is that actually for all requests, not only get, also for post, put, delete, all requests are going to be first handled, the requests are first going to be handled by this library, right? And this library will decide whether the request should be aborted, right? Or should it be let through, right? So the way the requests are handled are in the order in which the routes were declared. And the first one that matches, right, then it's the one who responds. Now, the request can also, once you handle a request, you can, by default, it just, the next thing is that it responds back, right? It goes back to the client. Or you can also just let the request go through so that additional handlers can take a look at it, right? So it's like a pipeline where you can string together several of these so that, in each handler, you do some work on it, maybe do some security checks, right? Maybe you check to see if the person's already logged in, whether they have a session or a cookie, right? And then, you can pre-process and massage the request as it's flowing through, each one of your handlers, right? Now, all these are configured to immediately send back a response. So the one that matches, boom, it responds immediately. Well, the course here, it doesn't, it matches all of the requests, right? So there's no really like a pattern match because they all match. They're all going to be handled, but it's going to let the request go through if it doesn't violate course configuration. Now, we're not providing any configuration here. Right? So basically what that means is that, hey, we're letting all requests through. It doesn't matter where it comes from. I don't care if it comes from a different domain, let it through, okay? And so once we have that, we're gonna restart the server. And let's try that again. In here, requests. And there it is. So notice that this time around, we did not get the course error. And the data that came back from the server is what, the request that we would expect, right? We would see in the response, it's the welcome to lab 5. We caught it, right? We got a hold of it right here in the client, right? This is the request that went out. We caught the response, and the data, the actual text, whether it's a string or an object or anything, is available in the response.data, right? That comes back from the server. Also notice that we're introducing here 2 new keywords, async and await, right? And what that means is that this command here that goes out to the server, it's actually an asynchronous call. And what that means is that, JavaScript has a thread that runs through our code, and it's actually a single thread. And so typically this thread, you want to make sure that you take good care of this thread because it's only one thread that you get. I mean, the browser has a whole bunch of threads. Notice that when we refresh here, notice that there's tons and tons of requests that go out, right? All these requests go out from the browser to the server. This is the Next.js server, and a lot of these are happening simultaneously. The browser creates several threads. Each thread is handling a request, right? And the response that comes back from the server. So the server has plenty of threads, but one of them is for our JavaScript running engine here, right? And so that thread, we want to take good care of it. One of the things that we want to avoid is that if we make a request out to the server, this can potentially, right, fail, right, indefinitely, where the server is maybe down and the request never comes back. So we could very easily get stuck waiting for the server to respond forever. Right? And so typically these conversations, these communication with these remote APIs, these other processes that are running, right? It could be running on my same machine. It could be running on AWS, right? Amazon, in the cloud, or it could be running somewhere in Eastern Europe. Okay, this server could be anywhere in the world. We don't want to have a tight coupling and be waiting for this server to respond. So what we do is that this is asynchronous in that the request goes out in a different thread. What happens is that the single JavaScript thread asks the browser, "Hey browser, you have a whole bunch of threads. Can you do this for me? Go and fetch this for me." And then I don't want to wait for it. I'm going to go do something else. Just notify me later on when the response comes back. I'm going to do something else, right? And then when you notify me, then I'll handle the response. Okay, but I don't want to wait for it. You go and get it, and then when it gets back, then you notify me. And that so to do that, to implement that behavior, that asynchronous behavior, and that integration with the browser with these multi-threaded environments, we use the keywords async and await. The wrapper function needs to be labeled async, and the actual invocation of the asynchronous call needs to be labeled with await, right before the actual invocation. Okay. So once you do that, the syntax looks very much like it's synchronous. Like this happens, we stop and we wait, right? And then when it's done, then we go to the next line. In reality, this gets compiled into quite a few other lines of code that don't look like this at all, right? And using the .then API, which is a little involved, and I'm not going to get into it. Async await is now the modern syntax of how to handle asynchronous communication. Okay. All right. Yeah. Oh, so notice that that we did go out to the server. I'm going to move this to the bottom. We did go out to the server. Okay. When we clicked on this button, we went out to the server, we caught the response, and then we displayed it here. Notice that we did not navigate away, right? We didn't do this like we go out and hit that URL and then get the no. We stayed in the same screen, right, and got data from the server, and then just updated our user interface with data that we received from the server. Okay, but nevertheless, it was on a deliberate clicking of a button. Right now, oftentimes we don't want to require a user to actually start some action. Oftentimes we want to do the request out to the server independently. In particular, we want to do it when the page first loads. The page loads, and then we want to go out, automatically go out to the server and fetch data. For instance, if we refresh the screen, for instance, right, and we lose all our state, oftentimes we want to recreate the state, right? And the server is keeping that state. So we would go out to the server, say, "Hey, server, I've been recently refreshed. I lost all my state variables. Can you give me a copy of the state variable to recreate the state and reinitialize the user interface based on that state that is being maintained on the server?" So here's a simple example, right? It's just like we had a state variable that we were populating populating when you click. This one's going to populate when it loads, right? When it loads, we're going to do the exact same, do exactly the same query, like this, right? But so we're going to do the onload. So onload, we're going to do the same thing, but we're going to populate this a different environment variable, right? This one, the welcome onload. Now this one runs when you click on the button. When does this one run? How does it get to run automatically? Well, the way it gets to run automatically is that we are going to use a new keyword or new function called use effect. Use effect, right, is equivalent to like a constructor. If this were a class, which is not, it's a function, right? In your constructor is where you typically would initialize the state of your object instance, right? Well, use effect is the equivalent to a constructor. It's what first gets, right? And it's a chance for you to do some preliminary configuration of your instance. In particular, for instance, do all your asynchronous communication, maybe go out to the server, right? And do all your queries, right? And then populate any state variables so that you initialize them so that when the page first renders, you already have some data to show the user interface, without requiring the user to initiate any action, right? So use effect runs, right? That's the first thing. When this gets instantiated, it calls fetch welcome unload, goes out to the server, it populates the local state variable, and then we are going to render it here. We're going to say onload, and we'll paste it down here like that. All right, and server. Okay, there we go. So let's try it out. Okay, so we go here, and then so notice that what's happening here. So if I refresh, notice what happens. Notice that it's already populated, right? Notice that, I mean, we only have a placeholder, but notice that when I refresh, boom, it's already populated because it goes out to the server without me doing anything. There it is. It went out to the server right away, came back with a response, and it populated right away. This one instead needs to, we have to click for it to go and fetch the data, and then we populate it, right? So we're going to be using this feature, right, this use effect quite a bit now that we are integrating with the server, right? We want to be able to populate data, right, onload and fetch it from the server. Okay. So notice that the communication that goes out to the server is this axios.get, axios.get, right? They're both going to the same place. Now, communication from components or even a page in a TSX and whatnot is usually considered to be bad practice. Just like we looked at Redux a couple of lectures ago, right? That you should have the concerns of different types of roles and different types of things that you do live separately, and so that you can deal with them more efficiently, right, for those types of concerns. So, for instance, in communicating with the server has a special set of skills associated with talking to the server, and so usually we don't want to mix communication with the server mixed in with user interface rendering. So a common strategy is to create a dedicated client file, right? And in this client file, you would implement anything that has to do with communicating with the server, right? So that all this code of Axios and servers and all that, blah blah blah, right? That would live elsewhere, like over here. Oops, what I do? Cut this. So we'll put it here. like that. And any function here where you have Axios, that goes out to a server, blah 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 blah, would live in a separate function outside, right? Like for instance here, fetch welcome message. You get the response, right, and then you send back the data. So that here you would only import the client. And so for instance, we would import the client like that, right? And this one would instead of using direct access to Axios, right, it would do const message, rate the fetch, right, and then this would be the message like that. See that? So that your user interface, your TSX file, doesn't have any code that has to do with communication with anyone, has no idea how the data is coming, right? We do know that it's asynchronous, but it's all hidden, all the details are hidden behind this client file, right? How the actual communication happens, right? So now you can dedicate your skills of communication with other remote servers, right, and remote processes in this file, which has its own concerns, right, and separate those concerns. And this only has, you use those functions, but you don't know what the details are, right? And you just use it so that you update the user interface. Okay. Okay. So here we are going to take a look at implementing a lot of the same exercises that we worked on in prior, in the prior lecture, right? That we were retrieving assignments, or we're retrieving the to-do items, whatnot, right? But re-implemented, within the client, right? Re-implemented using remote, asynchronous communication. So, for instance, for the assignment API, we're going to create an additional API that is going to allow us to communicate with assignments. We want to be able to fetch the assignment. We want to edit the title. We want to do certain things, and so we'll do that. Let's in the client we'll create another. The assignment API is just like here the welcome is the URL API is remote server lat5 welcome. For assignments it'll be remote server, and then lat5 assignment. Then later on with to-dos it'll be the to-do API lives at remote server lat5 to-dos, right? So it builds the base URL or path, right, that all our right, fetching data or sending data, they're all going to be based on that variable, that constant, based on the base URL of the domain object, right, and then the rest of the path. Okay, so fetching the assignment, right, is now using Axios to fetch the assignment, and so let's see, we can let's implement here an example. We'll fetch the assignment. Quickly implement this here in the file, and so we're going to have an object, right, that's going to be initialized as empty, and we're going to use the client to fetch the assignment. There it is. So we're going to fetch the assignment from the server, and we're going to do that unload. See that? Unload. We're going to fetch the assignment asynchronously. And then we're going to initialize the state variable, with whatever we get from the server. And once we have that, we're going to populate a local user interface to render that. We're going to render the title, the description, the due date, and we're going to populate our local form from data that we're going to fetch from the server. Okay. So yeah, so when unload, we're going to go out to the server. We're going to populate a local state variable, and then we're going to populate input fields, text area, date, pickers, right? Check boxes based on the the data that we're getting from the server. And then we're going to be able to edit it. Be able to edit it locally. You're using our on change. Now, obviously, we're going to copy it. We're going to be editing a copy, local copy. Obviously, we're not going to be editing the remote server object, right? Which we can, and we'll show you how to do that in a minute. So let's import this into our 5 page. So this would be, working with objects asynchronously. There we go. And okay, there it is. So notice that we refresh. It looks a little ugly here. Input field, I guess. Oh yeah, remove all the classes. So this is class form control. Yeah, that's a little better. Guess we can append all this. There we go. Dates. Okay, there we go. So this is the object that we're getting from the server. We can inspect and see that indeed on refresh, we're getting the assignment. There's the object, and immediately that object gets copied into a local state variable, and that local state variable is then used to drive the rendering of the screen, right, of the user interface. Okay. So yeah, so there's an object that we're retrieving remotely, and we're using it to populate a local form element. What about updating? We want to update the sequence. So for instance, what if I want to maybe update the title here, right? And then send it out to a server for update. So, so we already have the implementation using get, right? And we discussed that that was not the ideal way of doing it, but it's already implemented, right? It's assignment API title, and then you provide a new title, and it would update, right? And so that already exists. So let's implement that. Create an update function that we can call when we click on a button, right? And it will call the update passing the new title, and that we're going to pass in as an argument, and the response will come back with a new object with the updated assignment with a new title, and we'll update the local state variable so we can see the update if it's changed, right? And here we'll create a button that so that we can update it asynchronously. So we'll add it like right here. And so now we do have an update. There it is, update. And so let's do for refresh. It loads the assignment. There it is. And we can now make a change. Let's clear this out so we can see the request go out. When we click on the update title, so we click on it, and there it is. So there's the update that went out. Yeah, see that? The new title. And the response is the new object with the new data, right? With the new value. Now notice it's changed, right? Notice if I refresh the screen, see that? The change persists. Because now when I refresh, whatever I'm showing here, it's always going to be a class that goes out to the server. It is the server who's maintaining the state variable, the actual object in memory. So as long as the server is running, right, the client can survive a refresh. Something that is new to us, right? Up to this point, right, all our data has been living in state variables or reducers or some local data structure, and we could not survive a refresh, right? It would always reset the state of the React application. But here we have an alternative that allows us to maintain a state because it is being maintained by a server, which is not affected by the refresh of the browser. Right? Obviously, if we restart the server, then we do lose the changes. They're not really permanent, right? If we really want to make it permanent, this would have to go out to and stored in a database, right? So that would be a long-term permanent storage, and that will be the topic of the next lecture. How about arrays? Okay, so like we implemented earlier, we implemented an API that allowed us to create all the to-dos, remove to-dos, update to-dos. So let's try and do that asynchronous now, right? But in the client, we can now add the API, right, for the dealing with to-dos, right? So we can copy that, and in our client here, we can paste the to-do API that starts off with slash, lab5 and slash to-dos, and then this one retrieves all the to-dos. Right? And so let's create a component where we can play around with this, right? Here, working with asynchronous arrays. Again, we're going to have a state variable that's going to have a copy of the to-dos. Right? On load, we're going to call this fetch to-dos function, which is going to asynchronously go fetch the to-dos from the server, right, and populate the local state variable of to-dos. And then we're going to iterate over them to render them as a line items here, right? So let's import this in our lab5 page. This is working asynchronously with not objects, working with arrays, asynchronous. There we go. And yeah, there it is. See that? Those are the to-dos that we are fetching. Now, when we refresh, there's our to-do that goes out to the server. It's the same array that we were working earlier, but we were working with hyperlinks and at the URL. But this is not so much nicer, right? We go out, there's the same request that we were using earlier, either with a hyperlink or manually we're typing it. But in this case, we are capturing the response from the server. We're populating a local state variable, and then obviously iterating over it to display the line items. And so let's look at, once we retrieve these array items from the remote server, let's look at some of the common operations on this array. In particular, one of the more common ones is that if you want to remove a to-do, right? And we already had an API for this, right? For removing a to-do, right? The .delete, okay? And so here's just that we are interacting with that API, right? From the client, we're going to call it, instead of it being a link, right? We're going to be able to click on the to-do that we want to remove. It has a to-do item, and the ID is going to go out to the server, and it'll remove that to-do. And the response will be the to-do that comes back from the server, and we can populate that array locally. Okay. So as a user interface, right, we're going to create a state variable that it's holding the state, the to-do. We already have that. We're going to create an event handler for removing the to-do that takes in as argument the to-do object. Right. So here we have the remove to-do. It's going to use the client remove to-do, and the server is going to respond with the surviving to-dos. Right? And we'll call this with a in line item, we'll add a remove button with a trash can, right next to the line item. So in the line item, we'll put this maybe here, and we'll import the trash from there. Let's see. There's our trash. There it is. Yeah. And we can see that if we click on a trash like this one right here, there it is. See that? It removes. This is what the server went out, right? That's the request that went out. We want to remove the third one, and the server responded with the surviving to-dos, which we caught the surviving to-dos, and we updated the local state variable, and that caused this to re-render, right? So basically, the server is kind of like playing the role of our reducer, right? And obviously, right now, because we're not sharing data with anyone else, we're just using state variables. But once we start sharing this data across multiple screens, multiple pages, we are going to have to update the reducer as well, not just the state variables like we'll be showing you. And we can also create a new to-do, right? We'll have a create to-do using the same function that we were using earlier, using the get. Again, we said that it was a no-no, but that's fine for now. We'll use post in a minute. So here we can have the event handler to create the to-do, and we'll have a little plus circle that's going to allow us to create the to-do right here. So we'll add it right there so that we can invoke. Oops, not here. Expression must have a percent blah blah blah. Wait, to-dos. Huh? Oh, it's an force. There we go. And we'll import that. So we have, there's a plus sign here that's going to add a new to-do. Plus, there's our new to-do, where that came back with a new to-do down below. See that? The new task, and I can create as many as I want. And if I refresh, notice that the array survives the refresh, right? Because I'm always going to fetch the to-dos from the server that is maintaining the state. Okay, and then I want to maybe remove any one at once, so I can do there's several CRUD operations. Okay. We did mention that we were misusing get to do operations such as creating new items or removing items. The proper thing to do is to instead use post for creating, right? And using put for modifying, and delete for removing data from the server. Okay, and so let's refactor some of the operations that we already implemented for creating and removing and whatnot, right? To use the proper HTTP requests. Okay, so to do this, we're going to be sending data when we post. Right, we're going to be notice that our current creation always creates the same to do, just with new task. So ideally, we would provide some more information. We would provide the title. Maybe we can actually edit the title locally in a form and then create it. So we would need to pass to the server, the title of the to-do, maybe a due date, the assignee and whatnot. So the data would have to travel from the client over to the server. Right? And so to do this, we want to be able to send over JSON data from the client. So we're going to be, presumably we're going to be filling out a form in the user interface, and then we're going to collect all that data from the form, and we're going to send it over to the server so this can be inserted into the data structure in the server. So the server by default doesn't know how to parse JSON from the HTTP request. For that, we're going to turn on, from the Express library, we would have to turn on the JSON parser, right? And we do it as follows, right? Right after the course, in this order, right? You first initiate the Express library, then you turn on course, and then you turn on JSON parsing in that order. Okay, so careful. And so this one is, notice that these both are using app.use. So we already talked about course, right? Intercepting all the requests and then letting the requests go through. That means that after course have been successfully authenticated, make sure that there's no violation, then the request goes on to this one over here, right? And this is instantiates a JSON parser that is going to take the request that comes in from the client, is going to look at the HTTP body in the request and check to see if the content of the body contains a string that can be formatted as JSON. If it does, right, it's going to try and parse it as JSON. If it is, it's going to instantiate, parse the string, it's going to instantiate the JSON object, it's going to make it available to the rest of the request parsers, or the request handlers here, right? In the request object, there'll be a new request.body, right, where we can retrieve the JSON data, right? Already we saw that the request has things such as request params, right, that it has request.query. Well, there'll be a new request object called request body that will be added by this parser. It'll parse JSON from the body, and it'll make it available in this brand new request.body, right, which currently is null. Right? If there's no JSON in there, it'll just be null or undefined. Okay. So here it is. So from the we're gonna recreate. So we already have a function that creates a new to do, but right now it creates always the same to do. Instead, we're going to create a new version that is going to read the JSON, right, from the client. The client's going to send over the data in a JSON in the body, which we're going to use to create the new instance of the to-do. We're going to append a primary key here in the server, and we're going to push it to the array that we already have. So up to this point is the same as this implementation. Well, other than we're using the body instead of a hard-coded title. But notice the biggest difference here is that we are responding to the new object. So let me show you. So let me copy this and let's go to the server where we are working with the arrays. So we have currently we have this, there it is. See that create new to do? So I'm going to paste it under here, and there it is. So post new to do. So this is our current implementation, which uses the get, right? This one right here, this create, the get, which we said it's a bad practice. We don't want to do that. Instead, we want to do this. We want to send in the body the data, as opposed to hard coding it here. We're going to send all that from the client. We're only just going to provide the ID here on the server. That's a good practice to create primary keys on the server, not on the client. And we're just going to add it to the to-do. But notice what we were responding with. We were responding with all the to-dos. It makes no sense. I mean, if the to-dos is a really, really long list, you would be responding with dozens, hundreds, thousands of to-dos. That makes no sense. Right? So a more thing to do is to only respond with that brand new to-do that we just created. Presumably the client already has a cache that it wants, it's showing, it's displaying in the user interface, right? It retrieved it at an earlier moment, right? Retrieving all the to-dos. It already has a cache. So it doesn't need for me to respond with all the to-dos, only this brand new to-do. It was created, maybe even inserted in the database, right? With a new primary key, you need that information. I'll send you the brand new to-do. Now in the client, you'll need to be strategic about this, right? Because now you're not going to receive all the to-dos. You're going to have a cached version of the to-dos, and you're going to have a new to-do. So same thing here when we're pushing it, you two are going to have to push it on the client, right? Assuming that this succeeded, there was no error. Now to synchronize both of them, the happy path is just to both of us, right? Add to our local copies and hope for the best. Well, I mean, we certainly should check for errors, right? And then here's our post here. So instead of create, really properly, we want to post. Notice that we no longer have the need to use the verb create, right? We don't need that anymore because these the intent of creation is the type of the method of the type of HTTP method post. So you might be concerned that this URL, this path looks identical to this, but actually they don't, right? Because one is a get and the other is a post. So there's no collision there, right? It's clearly that one is a get, a post, and they don't collide. Right? They're in different namespaces, right? And so this ideally, right, it follows the best practice of not adding verbs in the path. Okay. So anyway, so I have that, and this time around we can't implement this because now we're using Axios, and from Axios I can generate a post. Before all these gets, there's no way for us to generate a post. We can only generate a get, with a hyperlink or typing the URL. All those are gets. There was no way for us to generate a post. Now that we have actions, we can generate a post, and so we can implement this, right? So now in the back of the client, in the user interface, right, we can generate the post. We can use actions now to generate the post, send the to-do object. Notice that this is going to have the comma to do. So this is going to encode the to do in the body. Before we were not having any comma here, anything, right? But now we do. So this data is going to be added to the body. So let's go to the client here, add the post. There it is. And now, right next to our create, we're going to add a post to do in the working with arrays asynchronously. So we have the create to do. Now we're going to have a post to do. And so yeah, we're going to send a new object, right, with the title that we're going to be editing in a minute. There's no way for us to edit right now. So we're hard coding on the client instead of hard coding on the server, but it's okay because on the client, we're going to be able to edit this in a minute, right? The next thing to understand here is that the new to-do is going to be created on the server. The server is going to reply with the new to-do object, with the new primary key, and presumably has been successful in adding it to its array. So what we're going to do is that we're just going to add it to our own array. See that? Because we already have a copy of all the to-dos, right? There's no point of you sending me all those to-dos. I have a copy of that anyway, right? So I'm just going to add it to my local cache. Obviously, this would have to handle any errors because the server might refuse to add the to-do for some reason. We have to catch that. If the server fails to add it to its array or to insert it in the database for some reason, then we should be able to catch that error and not add it to our local cache either, right? Again, always making sure that all the state across the multiple layers are in sync, right? Then we'll add another circle next to the other circle. So this one was using the old create. This was going to use the post. Okay. And so that's going to be here. Here's the one before was green. This one is blue, I believe. Yeah. So this one is whereas this one uses the get, right? And they all look the same, right? And it's being added at the end, and that's fine. Here, notice that we don't send anything. We just send slash to do's create. And we're not sending any data to the server. You notice that there's no data sent to the server. Whereas this one, this plus, it's calling to do. See that? Another URL, different URL. Notice that it's sending pre-flight options, saying, "Hey, what are my options?" It's asking for permission first from the server. It's saying, and the server's responding, "Oh, you're good. You can send me gets, puts, posts, deletes." And once that's successful, the browser actually sends the post, right? And but this time around, it's going to code and payload the actual data that is encoded in the body that's being sent to the server, which the server then appends to the array, in the server. If I refresh, notice that all those to-dos are in the array in the server, so that's good. It's remembering all that. Deleting, same thing. We had implemented using get, right? And we had said that was a no-no. The proper way to implement it is using the app.delete, right? With no verb at the end. Instead, we're going to move the verb to the method type. Okay. So on the server, right? This is the implementation of the delete, right? And I guess we can put this right next to the delete over here, right? Again, this might match the URL here, but actually it doesn't because this is a get and this is a delete. So there is no collision there. And it's calling the delete to do, which basically does the same thing, right? Of the remove Well, slightly different. Well, actually, no, yeah, it's the same exact thing. Finds the to-do and the index, it places it out. The difference here is that in our prior implementation was returning all the to-dos, okay? Um, and um, and so, like, again, that makes no sense. If you have a huge list of to-dos, you don't want to implement it this way because it could be hundreds of to-dos. Whereas here, we're just sending an okay. We're saying, yep, I'm good. I was able to delete it. Now you delete it too. A message back to the client saying, hey, client, I successfully removed it from my array. You should do it as well. Right? So the client, right, we are going to call this delete from the client. And the client API over here, I'm going to send a delete, right, encoding the ID of the to-do that we're removing. And then in the user interface, right, we're going to call, when we click on the remove button on a trash can, we're going to call this new, instead of this remove to do, we will call it the delete to do. So it's going to go out to the server, right? It's going to notice that we don't in our prior implementation we got the surviving to dos from the server. In this case, we're not receiving anything. We're just receiving a 200 saying, okay, it was successful. So I'm just going to do a wait delete client to do because we're not getting any data from the server. If this was successful, right? If we should wrap this in a try catch block, right, to see if it is successful. If it is, I'm going to filter it, just like the server filter it from its own array. I'm going to filter it from my own local state variable array, right? And then set the new array so that I only get the surviving to dos, right? So that it re-renders without that, right? And we're going to get a new delete button, right? This one's going to be the delete instead of a trash can. And so this will be right next to the trash can. So we'll put it right here. I'm going to import this. And so it's this one right here. Right, it's X. So it should work just the same way, right? And the only difference is that when we click on it, it works. So but notice when we're sending the ID, right? I was no payload and response just with an OK. So before it used to respond with the whole array of to-dos that survived. Here, we're just making sure that both of them are synchronized. Okay. And finally, let's take a look at updating a to-do. We were updating an individual title here. Here we're going to send a brand new object with whatever we update in the client, right? Where we presumably might have a form where you can edit the title, the description, the assignee, the due date, blah blah blah. All that information from the user interface is going to be sent over in the body, right? And what we're going to do is that we're going to just replace that particular to-do item based on the ID, so that we're going to swap out that old to-do with the new to-do, right? And then respond with 200 saying, yep, good. We were successfully able to replace it. And so this is going to be a message out to the client to do the same thing on the browser. So on the server, we have the update to do. And then on the client, we're going to call the to do. In the here in the client update to do, we're using the proper put, right? And encoding the new version of the to do with the new title, whether it's completed or not, right? Who is assigned to, blah blah, all that is sent over from the client over to the server, and here we have an edit to do, which is going to allow us to edit the title, right? So we can swap, change the local state of the edit. We're going to turn on a flag so that we can show an input field so we can edit it. And so let's see in here, let's add that. And the actual update is going to send out to the client, right? The new object that's been edited. So here, we're going to add a pencil at the beginning of the line item so that we can toggle the line item so we can edit it, right? There's a pencil here. Oops. So now, yeah, we're going to have a pencil here. Why are these? Oh, float end. I see. That's why they're rendering all the way. Yeah, let's look at the pencil right there. There we go. And so if so just going to toggle the flag to be true, so that as we're iterating over the to-dos, instead of rendering the title over here, we're going to replace it with an input field so that we can change the title. Okay. So yeah, so the input field here is going to say the checkbox. So the checkbox is going to drive. Where's the checkbox here? Yeah, checkbox. Yeah, here it is. It's going to drive whether we set the completed to true or not, and then if we're editing, then it shows the input field. If we're not editing, it just renders the title. Right? So that if I click on this, it changes to so we can edit it. And now I can change it to task 1, 2, 3, 4. Right? And notice that on every keystroke, we're sending the updates, right? And we press enter, it updates correctly. Notice if we refresh, the updates are permanent. You see that?